There's commonly considered to be three different types of t-tests. There's case 1, case 2, and case 3. Now in case 1, what we're going to say is that there's one thing that's going to be standard between them all, one thing that's constant. And in chemistry, that means it's going to be the same person doing the analysis, or the same lab or something like that. And what we're going to be doing is comparing something that's known versus something that was unknown. In other words, we're going to compare a standard where we actually know the real value, and we're going to compare a measured value. Now, we've luckily already seen the equation for this in the previous video. The standard way to handle this is just use a confidence limit. So if you know your confidence limit, and I'm just going to make up a confidence range here, at the, let's just say 95% confidence limit, let's just say that our limit goes from 1.00 to 2.00. This is going to be our measured set of values. If we know that our standard reference material has an actual value, whether it's concentration or whatever physical phenomenon we are measuring, if its real value is going to be 1.23, you can see that that does fall within this range. And so in this case, we cannot say with confidence that they are different. That's the way we want to phrase it. Not different at the declared confidence level. So we could say they are not different at the 95% confidence interval. If it was outside of that range, suppose that the value was 0.88, then we would say that they are different at whatever confidence level that is. Now notice that that can change. We can change what confidence level we have, which will widen the range that we have in our measured value, which will then eventually include our reference material. So if we want to be 100% confident that the interval contains our real value, obviously that means that our interval is infinity. We have to have every possible value to be absolutely 100% sure. We're always going to be something less than. Now that might be 99.999% confident, at which point we're going to have a very large t-value. And so we're going to have a crazy small standard deviation on our measurement in order to plug into this equation. So you can see that if we have a really big t-value, we have to have a really tiny s and a really big set of measurements in order to get that down to be something that's actually reasonable. So if we want to have really, really high percentage confidence, we need to make sure we have incredibly tight standard deviations, and we have to take lots of measurements of n. So that's going to be our case 1 t-test. In the next video, we'll do the case 2.